All right, so let me welcome you to another episode of our lesson. We are still looking at the circle geometry, that is circle theorem. Previously, we're able to look at two of the theorems. I give you three different theorems that we shall be looking at each of them. We are already done with two, so today we are going to continue from where we ended. All right, yes. So before that, let me introduce myself once again. My name is Evans. I'm your mathematics facilitator. This channel is Mathways TV. You can get Mathways TV on YouTube and TikTok. But don't forget to subscribe, like, and share the videos as well. All right. So today, what do we have? We are going to look at the theorem 3. And what does the theorem 3 say? So we have the angles in the same segment of a circle. Angles in the same segment of a circle. So when we talk of angles in the same segment of a circle, what does this theorem say? So we are saying that angles subtended by the same chord at the circumference of a circle in the same segment are equal. So if you have a circle, what this theorem is trying to say is that if you have a circle and have one chord, once you get angles at circumference, any part of the circumference in the same segment, once you realize that those angles are subtended by that same chord, then we are talking about what these angles are equal. So even if you have as many angles that you have, once you realize that they have the same chord, okay, then those angles are equal. That is what we are talking about. Okay, yes, if that is the case, then let's try and see, or let's look at what it is. Okay, so let's draw this circle, identify our center as O. Okay, yes, now let's get the chord we are talking about. So let's say we have this line segment which is the same as a chord. Okay, so we call it what? Chord AB. Okay, now let's see if you have angles that will share the same chord. Then I will decide to draw this line segment again and join it to B and call it C. So we now have what? A triangle that is um, ABC. Let's try and draw, but once we have this one, you realize that where we have C, there's an angle there. Okay, yes, but let's draw another one and then we join it together. So these are two triangles we have, but let's identify the angles at C and D. Okay, so we have M at C, and then we also have what? N at C. So we realize that these two angles, they have the same chord. Okay, the same chord, what? AB. And that is what this theorem is trying to say. Once you realize that these two angles have the same chord, and you can also see that these two angles are in the same what? Segment. So once they are in the same segment and they are having the same chord, then we say that they are what? Equal. Okay, so if you have M as angle 60 degrees, then automatically N is also what? 60 degrees. That is what we are trying to say. Okay, if that is the case, then M is equal to N, or angle ACB is equal to angle ADB. All right, yes. Know that we can even try to draw another line here, yes. And once we draw another line there, know that these two parts can also be chord. Okay, you can see that all those line segments are chords. If that's the case, then we can have an angle P here, which will be equal to angle Q, and also have angle R here, which is also equal to angle yes. So, and when you get this diagram, know how to identify these angles. Okay, these are some of the questions that you can get. Okay, yeah. So when you get such questions, you don't have to panic. Once you learn the theorem well, it is very easy to um, find your answers. All right. Yes. Yes. So know that even the diagram can be, you can see the diagram as this. Yes, you realize that A to C and B to D, you see that one is shorter than the other, but it doesn't matter. Okay, how the diagram looks like, it doesn't matter. At times, we give students such questions just to confuse them. But if you understand what you are doing, okay, because we always say that understanding of the question is also part of the of what your solution. So um, once you understand the concept or the theory that once they are sharing the same code, then they are equal. Then it doesn't matter how it doesn't matter how the diagram looks. Okay, so m is equal to n. Okay, we can even decide to draw that diagram, so we can still have this one. The same principle holds, nothing what changes. Okay, we can even decide to draw another one here. Okay, then we have angle P. Once you realize that the three angles are sharing the same chord AB, then you see M is equal to P at the same time equal to what? N. So provided M is 60 or 30 degrees, then it means automatically P and N are also what? 60 or 30 degrees. That's what we are talking about. Okay, yes, if that's the case, let's take this question. Let's look at this question. Okay, so let's say we have this angle and we have n to find what? Find the value of n. This is very easy. Okay, once you have this, you can decide to draw um, a chord here, down here, from P to Q. Then once you get P to Q as your chord, you know that automatically R and S are sharing the same chord. That is angle 30 and N, they are sharing the same chord. Then my N is what? 30 degrees. Very, very easy. Okay, now what confuses most students is that because there are times you will not get the question single like this, we may combine three or even more what theorems together, but because I'm teaching, we have to take them one after the other. Okay, yes, we have to take them single by single and look at each of them. Then when we are done with all the theorems, then you get the concept and understand it. So even if you combine 5 theorems, you'll be able to identify this is theorem 1, this is theorem what 2. Okay, yes, so that is how it works. Even we can even add plane geometry 1, angles, line segment, lines and all that, and combine what plane geometry 2 as well. So take note of that. All right, yes, that is it. If that is the case, then let's quickly look at how we will use our what do we call it, our software, that is GeoGebra. Okay, yes, to confirm that indeed angles having the same chord in the same segment are equal. Okay, so let's proceed and use our software as well. Great. Yes, so this is software that is play GeoGebra. Okay, this is a very nice software that helps a lot. So let's quickly proceed as we always do. Let's make the workplace what blank, and then yes. So for this one, let's quickly, because we've done this already in our previous um, video, we just go straight. So let's draw our circle. You come here, click on that and select your circle with center through points. Yes, you click on that, then you come to your worksheet, you click, then you drag to draw the circle to any convenient size you like. All right, yes, so that is our circle now. Okay, so for this one we are going to draw the chord. Okay, we are going to draw the chord. So this one will follow the same principle. We'll come here and then choose what? Line segment. In the theorem 2, we use what? A line when we were drawing the diameter, but this one we are going to draw what? A chord. So we are using a line segment. So you click on line segment. Okay, then you come down here or wherever you want to draw the line segment. Okay, you click here, then you drag it to, since we have point B already, we drag it there. Okay, yeah, so we have, this is our line segment. Then we come to C again, click here, and then draw another one here like this. Yes, we click here, and then join to B like this. Good. Then we come to C again, drag it here to wherever, any point at all you want to draw it. Then we click here, then click here again, drag it down to B, so we join it together. Yes, so this is what we have now. Good. So since we want to show that these two angles at D and E, they are equal, so I'll come to pick my angle. So I'll click here, select angle. So this one we are going to use the same anti-clockwise direction. So I'll click C. Okay, yes, come here, click E, then bring it down to B and click B. So we have our angle as what, 53 degrees. That is the angle we have at C. Now let's get the one at D. It will be the same as the 53. So I'll still click what, C. I'll go up, still anti-clockwise direction. I'll click here, then bring it down to B. I click B. So it's perfect, you see. So we realize that the same thing. Okay, so it's very, very nice, and indeed it is true. So GeoGebra has been able to help us prove that indeed angles of the same segment and circumference subtended by the same chord are equal. And you can see that angle at D and E are 53 degrees. This is very, very basic, and it is very, very simple. So when you have questions like this, you should be able to do this one. Now let me try and see. Let's do something. Let's try and drag it and see. So this one, I'm going to drag it down here some more and see if it will be the same. Okay, so you see that even as I drag it to look like this, it is still what, 53. Let me decide to also drag this one down some more and see if you see. So this one too, it doesn't change. It's still what, 53. Okay, this one is also what, 53 as well. So as I said, it doesn't matter how the diagram looks like. Once you realize that they are sharing the same chord, then definitely the angles are equal. So if that is the case, then let's end here and continue next time. So in our next video, we shall be looking at the theorem 4. Okay, so my name is Evans, and this is Amazvis TV. I'm still your mathematics facilitator. Don't forget to subscribe, like, and share the videos. Bye bye.